In this video, we're going to consider the cost of using table variables and temporary tables. There are a lot of things out there that compare using table variables and temporary tables, but here we're going to see that they both have disadvantages and why we might want to avoid them if we can. As background, let's mention that SQL Server uses what is called cost-based optimization to determine execution plans for queries. What happens is you submit a query, and SQL Server examines multiple ways of executing the query. If it has a where clause, the question is, does it filter first? Does it sort before it filters? Or does it do the join? What is the order of doing these operations? The order that it does them is going to dramatically affect the cost or the time it takes to execute the query. When it determines the cost of executing a query, it's not just dependent upon the query itself, it's dependent upon the data, the statistics about the distribution of data in the columns, the size of the tables, and whether indexes exist and what those indexes are. All that is taken into account. It's a complex operation, and we're grateful that SQL Server does it. If we execute the same query multiple times, it may have different execution plans, maybe because there are different parameters, but even if there are the same parameters, over time, the amount of data in each table may have changed, the distribution may have changed, and so it's going to select a different execution plan. Now, SQL Server uses cost-based optimization, but there is such a thing as rule-based optimization, which is what Oracle originally used. Rule-based optimization does not look for alternate ways of executing a query to see what's most efficient. It's dependent upon exactly the way the query is written. And if you write the query differently, to do joins in a different order, for example, it will execute the query differently. If you're the query writer, you must know about the distribution of data. You have to know much more about your data than you have to know to efficiently execute something in cost-based optimization scenarios. Now, getting back to the topic, why do we use table variables and temporary tables? Well, sometimes we have an operation which produces some intermediate results that might be used more than once. So if we can do it once and store it in a temporary table or a table variable, then we don't have to execute it multiple times for each part of an operation that we want. More often than not, though, I use them when I need to take something that I want to do and break it down into smaller parts that my mind can handle. Doing the thing all in one big query can be overwhelming. Now, there is a consequence. When we use temporary tables and table variables, we are telling SQL Server, at least in part, the order in which operations must be performed, and therefore the options available to SQL Server for the entire operation as a whole is much more limited. It's in individual steps where we've dictated how some of those steps should be executed. When we use temporary tables and table variables, we may need to tune how those are executed. But sometimes that's so complex, it might be easier just to rewrite the query without temporary tables or table variables if possible. Common table expressions can often come to the rescue because that permits us to separate out parts of a query in much the same way that we might separate it out for a temporary table, but it's still included in the query such that SQL Server sees it to optimize it all as one big operation. Now, one of the problems with temporary tables and table variables is that what we're dealing with may be so complex that we have no idea how to optimize the query. That complexity is the thing that caused us to make use of temporary tables and table variables. But when we use them and we don't have good performance, we may not know what to do next. So what we're going to do is look at a very simple situation where we're just going to make an arbitrary decision on how to use temporary tables and table variables to see what the consequences are. And we'll see that there are consequences. If we wanted to dig deeper, we would be able to see that these could be optimized. But that's the whole point. We don't want to be doing the optimization ourselves. We want SQL Server to do it. We're going to look at a scenario that is fairly straightforward. We have three tables, and they have cascading one-to-many relationships. If you've looked at my videos on naming conventions, you'll realize that these tables and column names do not follow the conventions I have discussed elsewhere. This database is from several years ago. We have an organization table that has a number of columns. The two relevant ones are org ID and organization name. Then it has a bunch of scheduling units in that organization, and the primary key for each is going to be the organization ID with a unit ID, and it will show the unit name. Each scheduling unit will have daily assignments, and the primary key there will be the org ID, unit ID, person ID, but we're not going to have a person table in this, an assignment date. Then we'll show the assignment code. So we have a one-to-many relationship and then another one-to-many relationship. Let's look at a query that would use this. What I'm going to do is join the organization table with the scheduling unit table, join that with the daily assignment table, and pull up all of the records for a particular unit ID. The unit ID is not an integer, it is a varchar. So let's just go ahead and run it. We get 168 records. We see that we have an org ID, we have the columns we expect. Data is not all that interesting, but we get some. Now, let's suppose that we decided for some reason to break this into two queries. Now, in this particular case, it's pretty clear that it doesn't make sense to do so. But the logic we're using is not all that different when we use temporary tables in other circumstances. What we're trying to do is take a big problem and break it down into smaller problems that we can understand. So the first thing we're going to do is put the data from the join of organization unit and scheduling unit into a temporary table. Now, you might say, well, why did I pick those two to join first rather than the second two to join first? And the answer is, when we're using cost-based optimization, we really don't want to care about the order that things are done. We're going to see that the order matters, but once we start using temporary tables, we are making determinations that take decisions away from the optimizer. So we're going to go ahead and put that in a temporary table, and then we're going to join that temporary table with the third table and see what kind of results we get. Once again, we get the same 168 rows. A third way of doing this would be, instead of using a temporary table, would be to use a table variable. And so we go ahead and create a temporary table. We insert into the table variable the same records we put in the temporary table, and then we do our final join to get the data. Let's see what kind of result we get there. Turns out we get exactly the same 168 rows. Now, a fourth way of doing this would be to use a common table expression. If we do that and put one of the joins in common table expression and then do a join with that, we'll see, once again, we get the same 168 rows. But the interesting question is going to be, what do we see when we look at the execution plan? So let's go ahead and run all of these and look at the execution plans. Now, I don't want to look at them too carefully, but let's discuss them a little bit. If you're not familiar with looking at execution plans, we're going to get one of these blocks for each SQL statement. To see how they're actually executed, you work from right to left, but the result is going to be in an icon here. It is going to show the estimated subtree cost, and the subtree cost is always going to be the cost of everything to the right of the icon we're looking at that's part of that series of operations. What the cost is really, for our purposes, kind of meaningless. The only thing that is important is the relative cost. And we'll see here that the cost in whatever units is 0.013025. When we go ahead and look at the second way of doing it, that has query 2 and 3, which I've marked as query 2A and query 2B because they go together, we'll see that we have two queries here. And if we look at the costs, we'll see that the query for creating the temporary table is 0.016 all by itself. So this part of the query is even more expensive than the entire query the first way we did it. And that when we add in the second cost, we wind up getting a cost of about 0.027, which, when these two are added together, turns out to be about twice what the cost above in the first method was. If we look at the third way of doing it, here, query 4 and 5, which I call 3A and 3B, we see that the cost is 0.016, and 0.061. So we get a total of about 0.077, which is about 6 times our original cost, where we just wrote the query in a straightforward way. And when we come down to doing things with the common table expressions, we're back to exactly the same execution plan and cost as we had when we wrote the query in the most straightforward way. So what do we learn from all of this? Well, as I indicated, I use table variables and temporary tables in order to break things down into multiple steps so that my mind can handle it. And that's okay. And if you do it and your performance is adequate, you're doing fine. But if your performance is not adequate, very often you've learned enough breaking it down into temporary tables and table variables that you can substitute those things into your primary query and eliminate them altogether. If not, you might be able to still simplify things without using table variables and temporary tables by using common table expressions. So the thing to be aware of is that the issue is not always between using table variables and temporary tables. It's whether you're going to use them at all.